this session is talking about like what is SBOM and VEX in software industry. So we have seen multiple sessions like the previous ones discussing about like what is an SBOM, what is a VEX, and I will give it a deep dive and I will try to explain like how we can correlate these two informations to secure our software supply chain. Okay, so my name is Rajan and I'm a senior software quality engineer at RedHat. So without any further ado, let's get into our session. So when I say software supply chain, I have to start with what is a software supply chain, right? So most of you already know about it, but I will try to recap the things. So software supply chain is nothing but any component or any piece of information, any tool that you are using to code, build, deploy, and monitor your application, which is known as software supply chain. That's it. So it could be a process, it could be a tool, it could be a library, any component that is part of a software supply chain. And this is a pictorial representation of like how a modern infrastructure looks like. So the software is built with multiple blocks. Every single block is very important. Like the previous session, I hope we had it before the lunch, right? They have shown a Junker box. So it's similar to that. Every single block is important over here. And anything bad happen to any of this block will disrupt our software supply chain. And what is bad? Bad is something we don't want to occur. That's it. So it could be CVE or vulnerability, but it is not limited to CVE and vulnerability. It could be a unmaintained third-party software, it could be a bug, it could be a license violation, and any other aspects which will affect our software supply chain, right? Which is called as bad. And what we want to know about something is bad is happening. So something which is bad is happening, we don't know about it. So that's where all the things are happening, right? All the cyber security. So something is always cooking at the background. And the second thing is something already happened, we know about it. And the third thing is something already happened and it is getting worse. So we have to make some countermeasure to save ourselves from the cybersecurity risks, right? So that's what all is about. And we have to address the fact like open source is already eaten out the world. And why I'm saying this, because 2 out of the three organizations thinks about open source when they start with a new application development. I'm not stating this. This is actually a report. And I have added the links at the bottom of the slides. So I will share it after that. And 96% of the code base is filled with open source. And with the 96%, 49% of the code base is not unmaintained for past 2 years, which is crazy, right? So that code base may have some of the previous attacks like Log4j, like SolarWine, and the most impressive one, what we have seen in the recent days, XE attack. Everyone knows about the XE backdoor attack, right? Because like in the movie John Wick, there is a quote about John Wick, right? He has a sheer will, and that's what you could see it from XE attack, because that guy was being part of the plan from 2022. He is cooking for every single thing, and then once he got the trust from the maintainer, he became a maintainer, and no one knows it. He just included a malicious package, which is crazy. So we have to take one step ahead of it, because the attackers are very deterministic and they are very motivated. So we have to be very much aware of the situation. And software supply chain attack is just a matter of when. It can happen at any time. Why I'm saying this? Because it has a very interactive nature between development and deployment, right? So it opens a lot of attack surfaces. So it could be part of your build process, it could be part of your coding pipeline. So it could be anywhere. And because of this nature, it becomes a target for the attacker's easiest target, right? So if we just put it on number, year to year, 156% of the growth in the malicious packages, which is crazy. And there's a report that states 45% of the companies will definitely undergo software supply chain attack by 2025. That's craziest. And finally, software supply chain attack is one of the 8 reasons for the data breaches. And finally, the ransomware. This is 500% increase compared to last year. The average ransomware payment improved to 500%. That's again the craziest thing, right? And this is not all of it. If we compare number of the vulnerabilities which has been reported in 2000, which is just close to 1,000, whereas at this moment it is 29,000 in 2023, and in 2024 it's again making the mark like more than 25,000. So all these vulnerabilities are always cooking, and what we have to do about it, that's where we are getting into the picture. And it's not just the ransomware, or it's just not the customer trust or downtime, even the data breaches. It becomes a regulation, because I am very particular about the US Executive Order 14028, which articulate about the use of SBOM in the software supply chain, which is very essential. So when I say software bill of material, that's what the topic is about, right? So let's discuss about the software bill of material. So software bill of material is nothing but a machine-readable, comprehensive inventory of all the software components and dependencies with license provenance information. It's a lot of words, right? So if you want to, or if you want me to simplify it, some people, even one of my team members, just told me like it's just a glorified version of dependency, but it's not. That's it, because with the dependency we will get to know all the dependent packages what you have used on your software certificate. Whereas in the SBOM you will have like more information which will give you the access to protect your software supply chain. And the information is about where's the code is originated from, who is the current maintainer, and it can have like the attestation, provenance information, everything that will help you to support your software supply chain. And we have different formats. We have seen it from the morning, right? So we have like SPDX and Cyclone DX. SPDX is from Linux Foundation. It's a more comprehensive, it's more established. My favorite is Cyclone DX, simply for the reason of it's very simple. That's the only reason. And it is from OS Foundation. It's more lightweight and it's gaining popularity. And before getting into it, I want to give you the glimpse of like how a SBOM file looks like. You might seen it already. Please keep it as a session for brush up your knowledge. Okay. So this is actually a Quackers SBOM from RedHat advisory. All this data is generally available, open to the public. So you can visit to the RedHat advisory page and you can get all of this information. So I'm going to start with SPDX. So at the top, I'm saying it's SPDX, right? At the top, you have the SPDX ID, and all these are all the metadata information. I'm going to skip all this part because of the simple reason we have to connect the dots between SBOM and VEX, right? What is the connecting dot? How we can connect the dot? That's the information that's available in packages over here. So under the packages, you could see, is it visible? I hope it is visible. Okay. So you can see there is external reference, right? And it is pointed to reference type, package URL, and you have the reference locator. This is actually the goldmine for SBOM. So from this, you can retrieve all the component, and this is just about a single package. And if you just collapse it, it will have every single package that has been involved on this particular SBOM. So what is report? Your manifest file, it could be a pom.xml, it could be a package.json. It has, you have listed up all your dependencies, right? That dependency is called as a direct dependency, and the transitive one, so whatever the child dependencies, it can be child of childs, everything is flattened out and given in array format, which is on the packages section over here. And if I just collapse it, there is another section which is relationship, where you can derive the nature of relationship between one package to another package. I told you it is pretty complex, right? The reason is there are like 45 different relationship type you can have between a package to A to package B. So this is pretty complex. That's why I don't like SPDX. Personally, it's just a personal preference. But if I just go into pom.json, this file is generated for a pom.xml and using a Maven Cyclone DX plugin. And I've been using a very outdated format. That's why you're seeing a Cyclone DX version with 1.4. But I'm going to metadata information as I skipped for the SPDX, and I'm just going into components. So if you want to put it head to head, components against packages. So in the components, you have all the dependencies listed out in the flattened out version. And if you just scroll to the bottom, you have a bomb ref, which is having the package URL for the same package. It could be, but it is not limited to package URL, to be honest. It could be a package identifier. It could be a CPE. It could be a Omni URL, something is there. Sorry. So it could be an identifier, package identifier, okay? And then if I collapse it, you could see all the details over here as well. So I'm going to collapse. So it's again an array. So all your dependencies in the flattened out format, it has been given with the component section. And finally, you have the dependencies. This is actually the specific reason I like Cyclone DX. So at the top, you have the reference, and then simply you put dependents. All the dependencies of your particular package, right? It would be listed out in array format. That's it. But it's kind of a complex nature. What happens is at the top you are looking at a Quackers REST right, which is actually a direct dependency for the project demo at 0.0.1.snapshot. So all these are all given with the manifest file, and if I just collapse it, you could see the Quackers REST starting from the beginning. And again, the Quackers REST uses two another dependencies, which is transitive ones. You could see them over here, and it's again started with the Quackers HTTP at the top. So it would do the same thing again and again until there is no dependence listed out. So if I just collapse and collapse, just there you are. You could see that, right? So the checkout annotation doesn't have any dependency. That's why it stopped there. But it won't be stopped at there. It will again do it in their own fashion. It will go to the next package URL and it will try to do the same thing to list out all the dependencies. But these are all required for if you want to compare between, if you want to derive a nature between a relationship between one package to another package, and you want to have a fancy way of displaying your vulnerability with direct and transitive. But for my matter, any vulnerability that is available on your product is making your project exploitable. So I will just focus on components. So anything that is available on the package, any package URL that has a vulnerability on your components or packages section, right? That's actually the important information. That's actually the gold mine from the SBOM. And I'm going to get back to the session again. So let me start the slideshow. Just a second. So we have the SBOM information. We retrieve all the package information. That's fancy and fancy. And then we have the vulnerabilities and advisories. So what is a vulnerability? Vulnerability is just an identifier, and it's just an identifier for any issue. A package has some issue, and that has been allocated with a vulnerability ID, and it is in the fashion of like a CVE and then a year and then XXYY format, and a unique identifier for that particular vulnerability. And advisory is an opinion or an advice or a remediation about a particular vulnerability. So this is the difference between vulnerability and advisory. And there are like multiple databases that you can see it over here. And if you ask me to give a simple example of like what is a vulnerability data, right? This is actually retrieved from CVE list GitHub project for CVE ID, CVE 2023-34455. And I'm going to skip most of the metadata over here, and I'm going to get on, where is it? Okay. So I'm going to skip over the part where I have the affected list. So here, so this is where you could see the package information. So if your project use any of the serial from the producer serial, the product snappy Java with a version 1.10 lesser than any of this version, right? That considered as affected. So once you have your SBOM, you have reached out to any database and retrieves all the vulnerability, right? If your product has this package, you will be affected with this vulnerability. That's it. So it becomes a vulnerability management, right? But that's what we are doing? No, not really. So we are getting in one layer above to see what is a VEX. So VEX is, to put it simply, VEX is a CSAF profile, and any document that has a CSAF profile is just a VEX. That's it. But that's about the theory part. In practical, we have seen a lot of session in the previous, before the lunch, right? So we've been seeing like how we can patch up the vulnerability and a lot of things. So that information is limited to the particular product producer. Say for example, I have vulnerability, I have a product, and I have mitigated a risk on that product, right? So I have produced a SBOM, and the SBOM still contains that particular package. So once I reach out to the vulnerability database, still I will be getting the vulnerable ID for that particular package, right? Are you with me? Is it clear? Okay. So we haven't shared the information like how we have mitigated the information with the VEX. So that's where the VEX get into the picture. So with the VEX, what we share is, okay, I have a package, I have mitigated the product with following these steps. So this product is not affected anymore. Even though this package is being used on your product, it is not affected anymore. I call it as, there are like 4 statuses. So it starts with affected, not affected, fixed, and under investigation. These are all the statuses which has been given by CSAF VEX profile. And I can give you the example for it as well. So this is again the CV 2023-34455 from RedHat advisory database. And if you take a look at it, this is actually the same CVAD if you look at it. And CV 2023-34455, it's just not the name, right? So if I just look into it, you could see the ID over here. So this is actually the ID of the CVE. And took one step further, if you just look at the product tree, it has all these products has been using this particular package. And I have to, I'm just trying to find where I can find the information, just a second. So here, so with the product status, even though these product using this particular package, it doesn't mean these products are affected. That's where the status does matter. So all these products are not affected because we have curated the data, and these products are affected because we haven't curated the data. We have to take some countermeasures. And finally, this we have one more status where it is known but it's not affected because there is something fixed and obviously there are some product which already has a countermeasure, right? Before knowing there is a vulnerability. So this product comes under the category of known not affected. Okay, so this is how the dots between SBOM and VEX file is connected. So to give you the glimpse of, to give you the overall, I can give you this picture. So if you take a look at it, SBOM is actually the most important piece of information. And then once you have the SBOM, you are retrieving all the packages and components from the SBOM. Once you have it, you are reaching out to CVE database to retrieve all the vulnerabilities. Once you have the vulnerabilities, the product might have like hundreds and hundreds of vulnerability. It doesn't matter. Yes. So it doesn't matter. So once you create a VEX file, the VEX file is actually from the producer. So the SBOM as well as the VEX file has to be from the software producer. And so you correlate these two information, finally you will get a report which will tell you what aspect of your product is affected and not affected, which is fixed and finally under investigation. This is how we are correlating the information. And we in the sense RedHat, right? So we have a strong affiliation with open source, and we are doing it with a trusted profile analyzer. This is actually the product which is being given for SBOM analysis, SBOM management analysis. It is capable of managing both SBOM and VEX document. It has a risk profile, and it is dynamically can be updated with database information. Where if there is an update on the OSV database or in the VEX file, it is capable of updating it on its own. And finally, we have you could create a new CV impact, and then you can look up for a particular package whether it is impacted or not, and you can apply the curated or trusted content. And finally, it can be operate on in-house or third-party software. What does it mean? As long as you are following the formats, the standards and the guidelines from SBOM and VEX, it is able to ingest the information and give you the result of it. And Trustify. So the thing what I have mentioned you about is an enterprise level project which is on the downstream, whereas the upstream version is Trustify, which is a simplified architecture with PostgreSQL centric, and it has a single binary mode, which is PM mode. So let me get into the point. So if you just go to the Trustify, all you can do, if you want to, so this PM mode is created actually for get into the feel and touch of the application. So if you want to get to know like how this project actually feels, right, you can easily, if you have Linux machine, just git clone this project. Once you have it, run the command cargo bin. That's it. It is actually built on the top of Rust. So with the cargo bin, it will pull out all the dependencies, and then within the fraction of a second, you will have the application. So I can give you the glimpse of it. Just a second. So I'm going to run this command. So I have already ran the dependencies, and I have pulled everything on this machine. So this is running on the localhost 8080. So if I just refresh it, where is it? Okay. So you will get this is actually the landing page where you can have the dashboard. I don't have any data, that's why it is totally empty. But what I have done is using the importers. Importers is actually the one of the useful functionality with this tool. Why I'm saying this, you can have the source data, right? It can be from, it's totally up to you. So if you want to have OSV or NIST, or you want to have the GitHub, you can just point to the source, and then it will automatically pull all the information and put it into your application. This is built on the top of the file storage simply because of the matter of I'm running on the local. So it can be attached with the S3 storage, or it can be on a clusterFS or Ceph if you want. So if you just roll it down, I will try to find where I have scheduled it. So you could see it, right? So there is a RedHat CSF VEX 2024. So 2024 is nothing but I have pulled all the adversaries just for the just started with the prefix CV 2024. So all the adversaries are pulled in, and you could see the 0%, right? So what happens is for the first time it will pull all the data, and from the second iteration it will pull for only the changes. If there are any changes, it will just pull the data and load it on your adversaries. And here you could see all the adversaries. So starting with CV 2024-0001 till CV 50207. This is actually the most recent one. Simply I'm saying because this is started with December 10, 2024. Okay, and if I want to, so this is just the adversary data, right? So if I want to upload any SBOM, I can just simply click on upload, and I can select an SBOM. So within a fraction of a second, it's already uploaded over there. And same thing goes for adversaries. I can click on adversary, click on upload, and select any adversaries. These are all the adversary information. So it will be uploaded with fraction of seconds as well. So this data is already available for you to explore. And if you look at the SBOM, you could see there is a Quarkus SBOM which is loaded with two vulnerabilities, because it might have like multiple vulnerabilities, but it will show only the ones which is affected for this particular nature. So you will have a nice dashboard at the top, and if I just go into this, you could have the status which is affected over here. And on the dashboard, this is what the interesting part, right? So once I have the dashboard, you could see the dashboard is updated with the Quarkus SBOM. So this dashboard is kind of like a repoll for every pull for every latest 10 SBOM files. So even though you have like tens and thousands of SBOMs uploaded into your system, it will have the last 10. But if you want to have an eye for a particular SBOM, right, what you can do is you can just click on the drop down, and from the drop down you can select SBOM. You will have the status nice and easy over there, so that you can keep an eye for a particular SBOM all over the time. So, and where was I? Just a second. So this is about the Trustify, and we have RedHat Trusted Supply Chain. So you can reach out to any of these places. So starting with the Trusted Profile Analyzer, which is my product, what I have demoed right now, and we have created an ecosystem, which is Trusted Software Supply Chain. So in the software supply chain, we have the certificate signer, which is apply the signatures, and we have a whole pipeline content, and that's known as a trusted application pipeline. And finally, what are the challenges that we have? We are the early adapters, and we have like lot of immature tools. Every day we are evolving, right? So we have a previous edition which is run with the base of Quack, but we have like some kind of inconsistencies. I won't say inconsistencies. It would be like there is some performance issues, and it is kind of like resource pooling, and it is not off the table. We are just not leveraging at this moment for the second iteration. And finally, inconsistent data. This is actually the most obvious reason for the challenges, to be honest, because we have like multiple different formats. We already know SPDX and Cyclone DX. We have SWID as well, and in Todo also we have a SBOM format. And the second thing is various identifiers. So starting with Pearls, CPEs, and we have like Omnibomb. So there are like multiple things that can be used as a various identifiers over here. And I have linked linked a report with the CPEs. So if you get a chance, please look at it, because that particular report states like CPEs will not be scalable anymore. So we have to always look for something that need to be identified as a product identifier. So once we have a proper standard and generic approach, right, then only it would be more feasible for us to move ahead. So these are all the challenges that we have. Any questions? So that's all I have. Thank you.